welcome to the presentation on selection bias. My name is Catherine Lynham and I am a student at La Trobe University. A bias is any trend in collection, analysis, interpretation, publication or review of data that can lead to conclusions that are systematically different to the truth. Yes, studies can mislead information. They can give unfair influences to sway predictions and population beliefs. Furthermore, selection bias suggests that the bias pertains to the selection of the sample. Therefore, it is not an accurate outcome for the entire population. Let's take AFL for an example. If you wanted to know which WA AFL team more Western Australians preferred, the following could occur. Selection bias sampling could be to sample 200 game goers dressed in West Coast fan costumes, attending a West Coast game where the other WA team, in this case Freo, was not playing. Sample example 1. Say there is 20,000 West Coast fans attending the game where West Coast plays an Eastern States team. 10,000 of those fans are dressed in fan clothing of West Coast. 10,000 fans of other teams attend and 2,000 of those fans are dressed in their fan clothing. If the sample is from a selection of participants wearing West Coast attire, selection bias would be seen. Results systematically trend in favour of West Coast being WA's favourite team. Here we can see that in this sample 200 participants were selected for survey wearing fan clothing, 0 from the other 3 categories, leaving the readers of the study to believe that 100% of WA's or Western Australians prefer West Coast. However, if you sample at random from a game where West Coast versus Fremantle, so a very even game, the results may differ. From this game, if you sampled 200 game goers at random in non-game clothing, the results would change. Here we see 100 selected West Coast fans wearing plain clothes and 100 from Fremantle wearing plain clothes. Of course, the researcher would not know that the fans were West Coast or Fremantle because they have no attire on that would suggest that. These previous examples are very unlikely scenario ratios. There is usually not one specifically more favourable, maybe only slightly. They're never 50-50 or 100, very rarely this case. These are purely for the example of explaining selection bias. Outcomes. By targeting specific participants within a population, the chances are increased to get the results the researcher is looking for. Take West Coast versus Eastern States. The chances of capturing which team is more preferred becomes more reliable when random participants are selected and testers are blinded from the sample group, therefore more accurately supplying the results for the target population. To avoid selection bias, the tester or testers should be blinded to the target population. Participants should be selected at random into the study or control group. No known facts should be taken on the participants, with the exception of any match criteria required to carry out the study. And the selection should be large enough to provide accurate information. To correctly analyse the data, recognising articles containing selection or any other bias should not be used to make predictions or to be relied on for the assumptions of that population. In summary, bias causes misleading information Selection bias can be conducted easily by choosing participants from the group the tester would like to see the outcome in favour of, and avoid selection bias by blinded random selection from a large group. Thank you for watching.